pretty much start the same way every week. We'll go through the homework first. Just go right around.
Chapter 2 homework?
Chapter 2. All right,
me to start?
John, yeah, if you want to start off.
The largest single component in an inboard engine is the B engine block.
Yep.
And number 2, the principal purpose of the engine block is to A, enclose the cylinders.
If anybody got that wrong, they'd get a demerit, because I think I pointed that out the last.
Specific, right? Steel or cast iron sleeves are used in aluminum engine blocks to C, absorb high stress and wear.
Yep.
Cylinder heads are A, removable and made of cast iron or aluminum.
Yep.
The engine crankshaft, liquid D, rotates within journals and bearings.
Piston rings, C, prevent leakage from the combustion chamber.
The piston and crankshaft are connected together by the C connecting rod.
The purpose of the flywheel is to maintain momentum between power impulses.
The basic purpose of the camshaft is to D, cause the valves to open and close.
Yep.
I guess
Marine engines used in inboard installations are usually of the wet sump design, meaning the component closing the bottom of the crankcase is the C, oil pan that contains the lubricating oil reservoir.
Timing marks are sometimes found on the D vibration damper.
12, what is a proper precaution when fueling an inboard gasoline engine boat? A, open all hatches, ports, and doors.
Open
Is
up.
that-
Open, oh, I screwed up.
Close.
Close all. Power.
Oh, I said open as well.
You're right.
Yeah, that's
awful.
One of
The-
those trick questions.
when you're actually
It is
fueling, you
closing.
close
Yeah.
them. Then
Yeah,
you should
then
open
you-
everything to air it out before you start to. Because if you look at if you follow the procedures that they recommend in this course, every time you fuel up, you'd be thrown off the fuel docks.
Yeah.
Because they put it, I've read and it's not just this course, but if you look at what they recommend, it's gonna take you a half hour to get off the fuel dock, and on a Saturday or Sunday morning, the people at the Marine aren't gonna be too pleased with that, so. Just as my basic rule of thought, what I've always done with my, like I said, I've got an express cruiser, is after a fuel up, I open everything up, I kick on the blower, and then usually I'll just lean over the rail and sniff the fumes that the blower's pushing out.
Oh.
And if I don't smell fuel, I figure that
You're probably pretty good.
that's
to go.
kind of a, it's a little safer than just going at it blind, but it doesn't piss off everybody at the fuel dock, because if you don't smell fuel, because that's literally pulling the fumes right out of the bilge.
Yeah.
Although if your boat explodes, then everybody would be really pissed off.
Yeah.
But you wouldn't
Our marina
get-
usually takes at least 5 minutes to actually run the transaction.
Yeah.
So we just run the blowers that whole time, and
Yeah.
we've never sat around waiting.
But it's surprising how many people don't even understand. I can't tell you how many people would pull up to the fuel dock and turn the blowers on when they're fueling. It's like, it's one of those things that one of the problems with boat, a lot of people don't take courses like this. And, they just go out and buy a boat and oh, well, it makes sense, if I'm gonna be fueling, I should ventilate, right? So,
Just sucks the fumes right into the boat, right?
yeah, yeah,
So maybe the compromise is closing the ports and windows that are close to where you're fueling?
well, generally, I prepare ahead of time, if I am getting fuel, I do generally close all the windows. You know, I close up the cabin, but like I said, the way I kind of make it quick is, as you pointed out, once you fueled up, you kick your blower on, and then you go up and do your,
While they're cashing that.
you know, you pay for your fuel and do whatever your transaction is. And then, like I said, my general way, I've always done, you know, my boat's small enough, it's not a bit, as I get on, I just lean over the gunnel, and I can take a quick sniff of the air that's blowing out of the,
This is only a concern with gasoline, not diesel.
yeah, gasoline is the one that's really, diesel is, I mean, obviously, you're always concerned of a fuel leak, but diesel is nowhere near as explosive as gasoline. And that's one of the reasons diesels are popular for marine applications, you know, safety-wise. It's a lot less. Diesel can still, I mean, you can still get in trouble with it, but it's far less likely to ignite. In fact, I don't want to get off on tangents, but I did one story I gotta share. I always tell us, you know, we talk about the safety of diesel. I was a gentleman I knew pretty well through scouting, and he was a doctor. He was a huge skier. He was on ski patrol, he was an instructor, he was actually very involved with some of the mountains up in New Hampshire, but he was an avid skier. And I always thought it was odd that, you know, this was a gentleman, was a doctor, not at all rough around the edges, very polished individual. And except he kept buying and driving diesel Chevy Suburbans. He had a couple of them. And I always thought it was weird. Finally, one day I asked him, I was like, Ted, why, out of curiosity, you don't carry anything, he doesn't do yard work, he doesn't, you know, his kids are all long since grown, why would you buy a diesel Suburban? He's like, it's safer. I said, okay, I mean, yeah, I can see it's safe, but diesel, and turns out when he was younger, he fell asleep coming home from a ski trip, rolled his car, it caught fire, so his solution to that was, from then on, every vehicle he bought was diesel because it wouldn't catch fire when he rolled it. I'm like, is there something with this? The logic doesn't quite add up. But anyway,
What kind of doctor
Moving
was he?
right along. Gasoline fumes, vapors are heavier than air. B.
Purpose of the carburetor is to provide the correct mixture of fuel and air to the cylinder.
The primary difference between carburetor systems and fuel injection systems is, fuel injector systems meter fuel into the intake air system.
Fuel filters are necessary to prevent foreign material from entering the carburetor or fuel injector C.
The two types of marine engine cooling systems are C, indirect and direct.
In the indirect cooling system, the coolant goes through the exhaust outlet pipe and is discharged overboard.
anybody else agree with that?
I had A.
A is circulating closed loop.
Yeah, and we actually will get into that, we're kind of ahead of ourselves, because we were supposed to cover that last week and we didn't get to it, but we're gonna.
That's paragraph 49. If you wanna look it up. I've got them all written down.
Jim
I
is
found an
every-
answer to every single one of these things right in the text.
Well, then how come we missed that? Open
I was gonna
close?
say it, I'm glad you
Because
did.
I answered it too quickly. I think I did the same thing you did.
Yeah,
Yeah.
I looked at that, I'm thinking, oh.
He saw doors and hatches, oh, that must
Well,
be it.
and, you know, when part of the checklist, when you're leaving the dock, that you open things up.
Is there another chair?
I can grab one from the other room.
Yeah, I thought we had it up there.
Sorry to be late.
Grab them there.
All right, in marine engine applications, the 3 types of cooling system pumps are, I think it's wrong, D. Impeller, lift, and centrifugal.
B.
Yeah.
I had B.
Yeah. Yeah, the correct answer for that is B. Again, we will get into, we're gonna get into that shortly, so.
Is there something called a lift pump?
It is, but it's I wouldn't call, a lift pump is not a type of pump, a lift pump is more a function of,
Right.
they have, a lift pump generally lifts fuel from the tank
I'm reading
to
that.
an injector pump or a carburetor. Whereas they're talking about the type of pump as being a gear pump, an impeller pump. But again, we'll get into that. We'll only get a couple more questions.
20, the 4 primary functions of the lubricating system are, I had D, lubricating, sealing, cooling, and cleaning.
Yeah.
A.
Hmm?
I had
Yeah, the correct answer is, oh, wait a minute.
It's actually, that's
Yeah,
paragraph,
D is the correct answer to that.
it's the last sentence of paragraph 60.
Well, there was something else there that was about pressurized, we talked about oil
Yeah,
being
I mean,
pressurized.
oils, a lubrication system does not have to be a pressurized system. So that's one of the, as in that, the little snow blower engine is showing, that's not it's a splash system.
But it's cleaning, I guess that's one by the cleaning system, more than lubricates, cleaning? It gets clean, but it's clean.
But, yeah, as in cleaning is to take the carbon, moisture, and even an engine that doesn't have a filter, like an old lawnmower engine, the contaminants settle down to the bottom of the crankcase and it drains out when you change the oil. So it is, the oil does act as a detergent as well.
The purpose of the oil filter is, remove foreign particles from the oil. Some questions on this?
What is the primary source of energy commonly found in the ignition system of an inboard gasoline marine engine, 12-volt storage battery? D.
Battery voltage is not high enough to cause a spark discharge across the spark plug gap. What device is used to increase the voltage high enough to jump the gap? C, ignition coil.
Yep.
The most common method of recharging marine storage batteries is by means of an alternator.
Yep.
Starter motors for marine engines, A, should never be operated for more than 30 seconds at a time.
In 24,
Yeah,
isn't an alternator a generator?
Mhm.
In question 24,
Yeah.
I mean, isn't an alternator a generator? So how is it seems confusing the way.
Yes and no. The difference, they are two different, they both serve the same function, but a generator generates DC current or direct current, and it directly charges the battery. An alternator actually generates alternating current, and then it has rectifier diodes in it to convert it to DC. So the terminology is, that's why alternators for alternating current, whereas a generator, and alternators tend to be they're much more efficient than a generator. Hence the reason that in modern times, most everything has gone from generators to alternators now. to have a 60 amp generator, you would have a unit this big that weighed 25 pounds, whereas a 60 amp alternator is this big and weighs 5 pounds. It's basically evolution of technology. You don't see generators much anymore in marine or automotive applications.
Okay. But it's interesting with that explanation. So you put an alternator in a boat that creates AC, then has to be turned into DC to go to the battery.
Yes.
But for your home, for power outages, you buy a generator that's creating DC, but then you somehow gets converted to.
No, most generators nowadays, and again, this is where the terminology gets
Okay.
fuzzy. Generator is such an accepted term, but honestly, the home generators are basically alternators. They're generating
Okay.
AC current.
Well, that gets to your point, okay.
So it's a little confusing.
Okay.
It's like when I was growing up, my dad was, he was a pilot, and he used to have it was one of his pet peeves that a motor was electric. A internal combustion engine was an engine. And as a kid, if I misuse those terms, he would call me on it every time. If I said, so-and-so blew the motor in his car. My dad would be the fan for the heat or the starter. Or, I was like, no, the engine. He's like, well, that's an engine, not a motor. But again, it's terminology.
So if the primary purpose of the alternator is to recharge the batteries,
Yeah.
then what's the purpose of, in like larger vehicles, having larger alternators or multiple alternators? I mean, like you can buy trucks with like dual alternator
Yeah.
packages.
Again, the key to that being the primary purpose is to recharge the battery.
Okay.
A secondary purpose
And
and it's just as important,
provide
is
DC power for
well, to
buildings.
provide, basically to be able to power all of your electronic devices.
Okay.
In other words, if you have a vehicle that's got, and again, we kind of cover this later in the course, but you've got a refrigerator, you've got an air conditioning unit, you've got a bunch of items that draw a fair amount of power. You've got a total that's drawing, you've got a total draw on your battery of, say, 50 amps when everything's running. If you've got a 35 amp alternator,
Okay.
it's just a matter of time before you're going to drain the battery. So a large alternator
Okay.
or dual alternators
dual.
allows you, and that's why dual alternators, usually in things like ambulances and
Yeah.
things where there's a lot of electrical equipment running.
Yeah, or like plow packages.
Yeah. And well, that's a
Yeah.
good example is a plow is
Yeah.
the electric plows nowadays draw a lot of power.
Yeah, okay. That makes sense.
And that's another, a lot of people don't realize that, how that all interacts. And I see it especially with plow trucks or Jeeps, people put a plow on. And I don't know, I can't tell you how many people over the years have been like, well, I need to put another battery in my Jeep because the battery keeps going dead when I'm plowing, using the plow. And I explained to them that you're not curing the problem. You're trying to compensate,
Yeah.
but if you're drawing more than you're replenishing, putting another battery is just gonna extend the amount of time before it's dead again.
Before you kill that one, yeah.
And that was one thing, I have an old Jeep that I used to plow with, and when I bought it, the guy had 3 batteries in it.
Oh.
Because he kept dying on him. He said, well, it's good for everything I do, but after, I was running a commercial plowing business, so that Jeep would be out, if we had a big storm, it would be out 8-10 hours. So the first thing I did was had a alternator rebuilder that I know build me a 100. It came with a 35 amp alternator. That's what was in the Jeep. It was a 70s 1977 Jeep, and so I had him build me a 140 amp alternator.
Whoa.
I took all the extra batteries out, and I've never had a problem since.
So is there something in the alternator that says the batteries are now fully charged, I'm gonna just start throwing an excess.
It's
energy
not in the well, it's, some of them are built into the case, but they use a voltage regulator that basically senses battery voltage and basically tells the alternator, okay, you can shut down or reduce, reduce the amount of output.
Is that covered later in the question?
And yeah, we'll get into alternators. Again, I don't wanna get too much into what, I don't wanna spend a lot of time on stuff there's a whole chapter on starters and alternators. In fact, actually, I think we get into it anyway in this. Alright, so if I recall, we left off talking about fuel systems, and actually we can get right into the cooling systems. We'll get into that question we were discussing a little while ago about direct versus indirect. Also referred to as open or closed. And basically the simplest way to describe it, a direct cooling system or an open cooling system is you're pumping seawater through the cooling jackets of the engine. You're cooling the engine directly with the seawater or lake water, whatever the boat's floating in. An indirect or a closed cooling system is like what's in your automobile. It's a sealed system with antifreeze in it and uses a heat exchanger, again, similar to the radiator in your car. The only difference being in a boat, we use a liquid to liquid intercooler, which instead of, like in your car, the radiator is taking the heat, you're forcing air through it to take the heat away from the coolant. In a liquid to liquid, you're using seawater, basically is pumped into the coolant goes through a tank which there's tubes in it which are surrounded by seawater is being pumped through. So a heat exchanger normally will have four or more liquid connections, and the fresh water or seawater side of the system is sealed from the engine side. And unfortunately, these diagrams are very the way they draw these are very complicated.
So in the heat exchanger, the coolant system is closed and it stays in the coils, and in the heat exchanger, which is like a tube, that whole tube is being flushed with the seawater?
Yeah, basically generally it's the other way around, but the coolant, the engine coolant is being pumped through a series of tubes, and then they go through the tank, and around those tubes is surrounded with has seawater being pumped through.
If you were to puncture the heat exchanger, seawater would drain out, right?
If you punctured it, both would. Well, I mean, you've got both
I'm just saying, like, the
fluids.
housing.
If you punctured the outer housing,
Depends on where
you would get seawater or lake water, whatever.
Not a good idea.
So
Yeah.
the main purpose of the indirect system is to cool the engine, and to cool the indirect system, you use the seawater to cool it.
The indirect system, well, basically both systems are using seawater to cool the end, or as
Right.
defined as the medium. But in an indirect system, you have you've got antifreeze or coolant that is being cooled by the seawater, which is then used to cool the engine.
Right, that's what I mean, so,
Whereas in a direct system, we're just pumping seawater through the engine.
right.
Um,
So when you have both of them, the seawater helps cool the coolant.
Coolant, which cools the
Cools the
engine.
engine.
Basically, just like in your
Right.
automobile,
Right.
the airflow through the radiator cools the coolant, which in turn cools the engine.
Right.
So in a
The air is
marine
the seawater in
system,
the car.
you're just substituting water for air as a coolant.
Right, so like, the air is like the seawater when, with dealing
Yeah.
with the car.
Yep.
And it's confusing, cause people will say, do you have a seawater system? And what they mean is, do you have a direct system? The seawater's going through the engine
Yeah.
to cool it.
Yeah, I haven't
But-
heard it called usually it's usually called
Raw-
raw water cooled
Yeah.
or
But
fresh
again,
water
you're
cooled.
like, yeah, there's raw water going through it.
Yeah.
So it's just confusing, cause
Yeah,
there's
that's
always-
another term, that's the common term, raw water means it's ocean water or lake water being pumped through the engine.
Yeah.
Which is all well and good if you're lake boating in fresh water and it's fairly clean.
Water and ocean
But
don't
if
get
you're, you know, if you're down in the Cape or you're in salt water, you know, the life expectant, I know like, and I'm going back now because it's been a number of years, but back in the late 90s, 2000s, down in Hummerock where I was, the life expectancy for a for a raw water cooled, I'm gonna say a Chevy 350, which is the engine that was in most of them, or cruisers and OMCs, pleasure boats. The life expectancy of those was 7 or 8 years, and they would rot out. You didn't wear them out; they'd corrode through the passages. After 7 or 8 years, you could put heads on. You could replace the cylinder heads because those were the thinnest castings, and you'd buy yourself another few years. But basically, 10, you know, you hit 10, 12 years, and this was average. I'm not saying people didn't get 25 years out of them, and you know, other people that have them rot out in 3 years. But as a generalization, that's why freshwater cooling is such it's an advantage, especially if you're buying or selling a boat. Freshwater cooling makes a big difference.
So on that one, going backwards again for raw water, because I did have a raw water boat, and I just had issue after issue with it, to the point we just got rid of it, and I'll be outboard for the rest of my life. But I was at 370-ish hours, but when I bought the boat, it was used. The person prior had overheated it, they basically melted they kept bringing it back, it was thermostats, it was this. So they melted the coupling from the engine itself to the stern drive, so eventually that was fixed for 5,000. And then I got oh, by the way, we're gonna hit you up for manifolds and risers in about 25 hours, so get ready for another big repair. So the manifolds, I understand, but are the risers what so it goes through the manifold? Risers bring it up to go out, but he was pretty much
basically
saying all of that was crapped up and.
Yeah,
get
and
ready
that's
for
very
another.
common, right? And even on freshwater cooled engines, very often the manifolds are not included in that. Oftentimes the manifolds will still be raw water cooled. And in almost all cases, the risers, they call risers as a terminology, usually the part that bolts on the manifold and it brings the level, they basically raise the level of the exhaust output so it's above seawater, it's above, they call them risers to get them up. It's kind of a generic term, but,
So are
and
elbows
those,
the same as risers? Are elbows the same, because you kept using terms,
yeah,
risers.
elbows are another common term, that's the same, you're talking the same part.
I want to say in our boat that the seawater, so the seawater goes through the heat exchanger
Yeah.
to cool the engine coolant, but then it also goes through another for the transmission, and it cools the transmission fluid. Is that
Yeah, that's possible.
Yeah,
Um,
yeah. But then, like you said, then the raw water goes
But
through
then-
the exhaust.
Yeah, a lot of
manifolds,
times what
so you-
happens is if you have that heat exchanger, the water coming out of the heat exchanger will normally then be routed to either the exhaust manifolds or just the heat, or just the risers.
Yeah, ours goes through the
Um,
manifolds, so we have to do new manifolds.
I know when I replaced the engine in my boat years ago, and when I did, I put a freshwater cooling system on it.
there was a sentence that said, when elbows or risers are used, they will require maintenance.
Yes.
What's the maintenance?
Normally it's to pull them off and inspect them every, again, that varies depending on the conditions you're operating under. You know, again, down where we were in Umrock, I used to recommend every 4 to 5 years to unbolt the risers, take them off, and you can, when you take the riser off, you can look right into the water jackets of both the riser and the manifold, and you can see how badly rotted they are. Because a rotted manifold or riser can end up costing you an engine, because you'll actually end up pulling seawater back into the engine.
So it's not maintenance, it's inspection and replacement before failure.
Yeah, there's not a lot of,
Not much you can do about it.
but that's, to me, it's part of the maintenance schedule is to inspect those,
Right.
and as long as whoever's working on it believes in anti-seize, it's generally not a huge deal to pull the risers. Now, obviously, it varies boat to boat, but compared to most any other engine work, usually they're right on top. And the other thing that, you know, if you've got a multi-engine boat, you've got 4 sets of, you know, you've got 4 risers. You know, if you pull the first one and everything's in good shape, you generally can be like, okay, we'll let it ride for a few more years. You don't necessarily have to pull all 4 of them.
Yeah. We have stainless risers in our boat, so we really know life out of them. In theory.
Another 6 months?
You know, that would all depend on the grade of stainless.
Yeah. True.
And the one of the things, I'm a big believer in stainless. However, you gotta be careful of that, because as you get alloys that are more resistant to corrosion, they now become brittle and they're prone to cracking. So there's always a balance there of, you know, stainless isn't always a good thing. Although honestly, in a marine environment, generally it is. All right, so all right, now for most of these, particularly inboard engines or stern drives, inboard outboards, you generally are going to have at least two water pumps. You'll usually have a pump, well, as you had said, you could call it a lift pump, but you'll normally have a pump that will pull the seawater up and push it either to the engine if it's raw water cooled, or to the heat exchanger if it's freshwater cooled. And then you will also have a circulating pump on the engine to pump the water throughout the engine to cool it evenly. This is a centrifugal pump. This would be a circulating pump. It's normally on the engine. This pump would be used to circulate the coolant, if it's a closed system or freshwater system, this would be pumping the antifreeze throughout the engine and pumping it through the heat exchanger. It's a centrifugal pump because as it's spinning, it literally is, if you look at this, the coolant is going in through this big rectangular, it's being pulled in there, and as this is spinning, it's literally a centrifuge. It's throwing the water out into these two passages, which these are lined up with holes in the engine block. So it's taking the water in here and pushing it out through here. And These are usually, like I said, these are used to circulate water, but a centrifugal pump will not pull a head of water up. In other words, if you've got the engine, if the level of this pump is above the water level, the pump doesn't work. It will not create a suction to pull the water up. Hence the reason that you will need a raw water pump. It's often referred to as a raw water pump or a lift pump, but a pump that is generally below the water line that pushes the seawater up to, as I said, either the heat exchanger or up to that pump so it can circulate it. In a closed cooling system or a freshwater cooling system, the system's always full, so the centrifugal pump works fine because it doesn't have to prime itself. It's always submerged in coolant.
But if you have to take off the circulating pump to service it, or you drain your coolant, it's not self-priming. So how does it manually get primed when you do either of those two things?
Because that will be mounted in the coolant, so it will be mounted low enough in the system so that when you fill the coolant, it will be above the level of that pump.
Okay.
And it's a good point. So certain applications require a specific procedure to get all the air out of the cooling system if it's a closed system. Again, if it's a raw water system or an open cooling system, there will be another pump that will supply that, so you don't have to worry about bleeding it. I will try to remember next week to bring in the raw water pumps are generally a rubber impeller pump. And it's going to actually I'm actually doing a lower unit seals on a water pump in a 45 horse Mercury right now. I just took it apart this weekend. I said, oh great, I'll bring this old impeller in, as it's actually starting to fail. I can even show you what happens to them. And of course it's sitting on my bench.
Thank you, snowstorm.
No, thank you, lousy memory. I'd like to blame it on the snowstorm, but that was Sunday. It wasn't snowing yet. All right, before I get too further into the pump, is everybody fairly clear on the freshwater or open or closed cooling versus raw water? Like I said, the easiest way to remember it is raw water or open. You're cooling the engine with the water that the boat's sitting in. Now getting to the discussion on pumps. We have the three different types: centrifugal, gear, and impeller. You're passing around the centrifugal. This is a gear type pump. This is actually this is what's used for an oil pump, and there's different variations, but this is basically what they use for an oil pump in an engine. It's a positive displacement pump, meaning unlike the centrifugal pump, for every revolution of this pump, it's going to move a given amount of oil. And hence it's a constant displacement. Whereas a centrifugal pump, depending on the resistance, it'll move, a lot of liquid or very little. And these actually work backwards from what you'd expect. They show it in the diagram. You can look at it, but the way this works is, you'll look at this pump, you'll see there's holes that go into these two cavities, and then normally there's a plate across to block the front. So if I'm holding it here, as these gears are turning, it will pick up the oil, and it takes the oil around the outside. Basically, the oil fills the spaces in between the teeth on the gears. On the outside of the pump as it's turning, Well, because the gears are meshed together here, the oil can't really go through there. So it actually picks up the oil, runs it around the outside of the pump, and then because the gears are meshed, it can't go back through the middle, so it pushes it out the other hole. Those gears will fall out if you turn it over. That actually happens to be out of an old Volkswagen Beetle, an old air-cooled. But that's again, a very standard oil pump. Again, most of the Merc Cruisers, the older stuff, they all use pretty much that exact same design pump.
Do they ever fail?
Oil pumps wear out. However, and this is something I can't, again, how many times people will say, can you replace an oil pump? My oil pump pressure is low. The oil pump is part of a whole oiling system. Very, very rarely does just the oil pump wear out. Usually I have to explain to people, look, if you've got low oil pressure, if the pump's worn out, that same oil's been going through your entire engine. Chances are, if the pump's worn, so are the bearing surfaces, there's usually a lot more to it.
And is that inside the engine or is it sitting outside the engine?
It depends on the engine. Most modern engines, it's in the oil pan. You have to take the oil pan off, okay. So it's not internal per se, but it's still the engine's still got to come out to get to it and take the pan off.
And there's no bearings or anything in this because
no, they're just a sleeve bearing where
the whole thing
spins.
is swimming in oil.
Well, it's also this pressurized oil,
yeah.
So it's pushing it. It's keeping those surfaces. This is actually another style, and this is more like what you're going to see in your Merc Cruisers. And it's a different style pump, but it's still a positive displacement pump. And you can turn, it's the same idea, it's a similar idea that it picks up oil here, and as this turns, it pulls it into these spaces filled with oil, and as they get over toward the other side, the space closes up, which pushes the oil back out. There's a hole to the inlet and outlet. Again, this will fall out. So. And that normally bolts and hangs down into the oil pan. This is normally submerged in oil.
So when you say a Merc Cruiser, would that be an inboard output?
Yeah, well, inboard or it could be either one. It's an inboard engine, whether it be an IO or a straight inboard.
Yeah.
And again, those are both considered gear type pumps. The third one would be a rotary pump or a rubber. I call it rubber impeller. It's normally, but an impeller type pump. And I will next week. I'll remember to bring. I'll bring an impeller pump with me so you can see. All of these pumps, like the gear pumps, the impeller pump has passages or chambers that start small. As it's rotating, they get larger to pull more oil in, and then they get restricted again to push it out the other passage. Now, a rubber impeller, like these do it mechanically with multiple gears. A rubber impeller pump is just literally what sounds like a round, what am I thinking of, like tube with fins on it that are rubber, they're flexible. So as it rotates, those fins straighten out to allow a large, like you see in the gear pump, a large area between them. and then they kind of fold in on themselves. The center of the rotating piece is offset for the hole that's in, so it squeezes them down and restricts them. But the thing with a rubber impeller pump is those fingers are constantly expanding, they're flexing all the time when it's running. And which is the reason that they need to be replaced every few years. And again, the best way, I'll bring one in next week. I just have to remember to, well, part of it I have to clean it, because if I bring it in right now, you'll all go home with black hands.
Rusty, I've got a Jabsco raw water pump on my boat that's no good.
Yeah,
I can bring it in if you want me to.
but, yeah, I mean, yeah,
It's
if
in
it-
color, yeah.
yeah, or I can get it from you so I can clean it up first.
Okay.
And it says in the book that type is self-priming.
Yes, those are self-priming because it's a rubber, you actually get, it pumps air as well as
Okay,
water.
okay,
So it will actually pull a vacuum to pull water up.
okay.
That's the big advantage to the rubber impeller pump, it's self-priming, whereas none of these other ones are not.
Okay. Because we replaced those on our boat, and I thought the mechanic said that the new pump, the impeller got cooked because there was no water.
Yeah, that is one thing, that's one point with these impeller type pumps, the water is the lubricant for the pump.
Yeah.
So running them dry, you can ruin one of those pumps very quickly by starting it. And I know even a place, a marina that I used to, years ago, I can remember when I was a kid, my dad used to have the boat serviced, and we would tailor the boat home. It was a 16-foot boat with a 35 horse outboard. We'd stop on the way out, and they would lift the motor right off the back of the boat. The marina would winterize the engine and store it for us. And then in the next spring, we'd come down with the boat, they'd plop it on, and they'd hook it all up and just fire it up to make sure it starts with no water or anything. Looking back, I'm like, they were taking years off the life of that impeller doing that.
Right, right.
Because there's no, especially if it's been sitting all winter, stored indoors.
But, okay, but even though it's self-priming, you can still cook.
It still needs to
you can
have
still
water.
cook the impeller by.
I mean, as long as it's
by
in the
running it
water,
dry.
you'll be okay.
Okay.
I mean, as long as there's water available, within a couple revolutions, it will get lubrication.
Okay.
But it's also the reason, just as a side note, if you're doing your own work and you're flushing out the boat, running the engine on either a set of the muffs for the outboards, or any sort of water supply that you're running it on out when the boat's out of the water, it's fairly important that you turn the water on before you start the engine, and you don't shut the water off till after you've shut the engine off.
Right.
The diaphragm fuel pump has a diaphragm, does that ever wear out?
They do.
Then you have to replace
Usually
the
what
whole pump?
happens, they don't so much wear out. Usually what happens is the diaphragms get brittle and crack, and then they start leaking.
So do you have to replace the whole pump, or can you service the diaphragm?
You technically, a lot of the older stuff, you could service the diaphragm, but good luck trying to buy one.
Okay.
In this day and age, you just buy a whole new pump.
Okay.
And the new ones are never serviceable. The old ones are held together with little nuts and bolts, and
Okay.
I'm sure, I say old, I'm talking probably 50s and 60s.
So there's no maintenance on the fuel pump?
No, there really isn't. And even the serviceable ones, there's really no maintenance on them. And they have basically the diaphragm pumps, as in like the fuel pump, has the two things that go wrong with those. Either the diaphragm rips, or the other thing that's common is the diaphragm pump has check valves that allow, there's one on the inlet side that will allow the fuel into the pump but it won't allow it to go back out. It's just like a little flap of rubber on a lot of them. And then on the outlet side of the pump is the opposite. They'll have one that'll allow fuel to go out but not back in. So that way, every time the pump moves, it'll pull fuel up from the tank and then push it out to the carburetor. But the valves won't allow it to go the other way. It's common, those valves also will fail. And then basically what happens is that it stops pumping, the fuel just keeps going like this back and forth, it doesn't actually move. I've seen that. And that also happens if you get dirt, if you get contamination or dirt in those valves that keep them from closing. Okay, I say how quickly. Oh, you know what? I take it back, I do have an impeller pump in here, I just haven't cleaned it up. This one's not too bad, but you can look and see exactly what I'm talking about, how this rubber impeller spins in here, and you can see how the one side of this is the water in, this large side here would be the water intake, and again this would be up against the, this is actually I think off an OMC outdrive, and as the fins get squashed down, it would push the water out the other side. I had forgotten that I put that in there. But as you can see, these rubber things, like this one here actually isn't failing yet, but these little rubber ears are constantly flexing. So that's the rubber impeller pump.
So would this be something that you replace
You
periodically
Yes.
before it fails?
Yeah, again, it depends on the waters you're running in.
You should check them annually.
It also, it depends on, and
Replace
even
yours
that,
annually?
I don't replace them, I check them.
it depends on what it's in.
Yep.
You know, if you've got you've got like a Mercruiser stern drive, that's a $300 or $400 project to look at it, because you have to take the drive off the boat, take the drive apart. So, I'm
for
probably
those.
not gonna do one of those annually. I'll probably do one of those, I'd probably do every 4 years.
To replace one of those.
And honestly, for the amount of labor, that impeller's probably 15 or 20 bucks. You know, for the amount of labor to get to it, if you take it apart, you might as well change it.
Yeah,
That's right.
yeah.
But it is something, again, you kind of want to get a feel for where your boat is, the marina where you are, talking to other people that have similar boats to see, you know, what's the kind of the rule of thumb where you are. And I found, as I said, I am at two opposite extremes. Down in Hummerock, you know, this kind of stuff we're doing every few years. I have my other boat, which is also a Mercruiser stern drive, up on a lake in Maine, and people up there are like, oh, no, you change those when they break, which maybe, you know, I don't know, my boat, mine's been up there now for 15 years and I've never changed it. I haven't done any of this stuff we're talking about.
Yeah.
But it's a freshwater lake. Also, my boat's stored in a barn, so it's, I mean, it's pretty good, a pretty easy life.
It's stored dry then.
Yeah.
Yeah.
And it,
We had one of those fail, so we just replaced
yeah.
both at the same time, just as a
Yeah,
preventative measure.
you definitely should. And the other thing that when one of those rubber impellers fails, you really should pull apart the heat exchangers, because oftentimes those rubber fingers will be trapped in the heat exchanger. So you get your new pumps put in, and the first time you get out there, all of a sudden you're overheating again, because the rubber fingers block the water flow going through the heat exchanger.
That happened to me.
again, that's kind of more of a call for the mechanic. When he takes it apart, are the fingers gone? If the impellers are still intact, then you're okay, you don't have to really worry about it. But if the fingers are broken off, and like I said, I'll bring in one next week that the fingers are starting to break off.
Disintegrated.
So if you can't find, if you're pulling one of these things out and you can't find a piece of it,
It's in
you
the-
need
Yeah,
to
you
find,
need to
you
find
need to
it.
find
Yeah,
It's
you
in the
it.
need to
engine
know where,
somewhere.
well,
Yes, you need to find it.
Yeah.
well, you need to make sure it isn't somewhere it shouldn't be, because the
Right.
other possibility, it may have broken into small enough pieces that it went right through and out the, so you're not absolutely gonna find them. But,
Wanna check.
you know, to
Yeah.
me, I'd wanna
If
know,
it-
and
If
again,
it
honestly,
erodes,
it
as
also-
opposed to just like exploding.
quite frankly, it also depends on the type of use you get, you know, where you are. It's like, on my outboard on the lake, I would probably be like, okay, well, I'm gonna take it up the lake and see if it overheats. You know, if it does, then we'll throw it back on the trailer and figure it out. But, you know, my 28-foot express cruiser out in Cape Cod Bay, I'm probably not gonna take the same approach, because I don't wanna be stuck out there.
And that's after your sea strainers, right? So those pieces
Yes,
wouldn't be in
you
your
know, they
sea
wouldn't get
strainer
in the
know
sea
that these are
strainers,
off-center a little
they're
bit, so
after,
this-
the strainers are
I didn't know
before
that.
those pumps.
before that.
You know, for my raw water pump, there's actually a room.
Again,
inside-
most-
Inside that these things.
Most
Flush
decent
it.
mechanics are gonna be aware of, they're gonna, if they do that job and one of the pumps is blown apart, they're probably gonna recommend, hey, you really need to do this. Alright, and the next thing I'll just pass around the thermostat. Because basically most all of the engines operate much more efficiently at a warmer temperature than, particularly in a boat, you know, in the ocean. You know, most of these engines are much happier running at, you know, 180, 190 degrees, 150 versus 60 or 70 degrees. So basically what this thermostat does is blocks off the water coming out of this centrifugal pump. It's one of the reasons I use a centrifugal pump, because this pump doesn't care if you block the water flow, it just spins, it doesn't really bother it to not be moving. And so
Interesting.
That is interesting.
there is a little wax pellet in here. As it heats up, it will push on this little point here and open the valve in here. This one I'm going to pass around as a fail. This thermostat has failed. It's stuck halfway open. So this is allowing coolant. When the engine's cold, normally that should be sealed. You shouldn't be able to see the coolant flow through there. This end's down in the engine block, so it's sensing the temperature of the water in the engine. This end would be headed toward either the heat exchanger, if it's a closed system, or the water outlet to the manifolds.
Meanwhile, that pump will keep on pumping and it won't matter.
It won't matter, because basically it'll just stop, the water won't move, it'll just spin without actually pushing water if there's no place for it to
I didn't
go.
know that.
Which is why if you used a pump like this to circulate the water, something would have to give.
Yeah.
Because it would, you know, you move water, it would have to move, whereas a centrifugal pump, the water doesn't have to move. Secondly, some of it is always moving because the back end of this seals off another passage that as this one opens, this one closes off, and vice versa. This lower passage bypasses the engine and allows the coolant to go right to your manifolds.
Okay.
So you always have water flowing through your manifold. All this does is
Always got
restrict,
Water coming out.
Yeah, so there should always be water coming out.
Oh, that
And
makes
it just,
sense.
this thermostat controls basically the direction where the water's going. When the thermostat's closed, the water's going through the engine to cool it.
And then,
Sorry, I go the other way around.
It's
When it's
open.
closed, it's not allowing the water, it's bypassing the engine, just
It
going right out
goes
to the
like,
manifold.
You know, straight, basically to the manifolds, to the exhaust risers, and then.
Yeah, so basically it's bypassing the engine. When this thermostat opens, this end closes off that passage, it goes directly to the manifolds and makes the water go through the engine first, then out to the manifolds.
So what you were saying is when it runs better warm, so it's gonna shut down till it gets up to temperature, it takes, the
Yeah.
wax thing gets hot, then it.
Yeah, when it
Then it lets the
expands, it will
water-
open like you see it here, and as the engine temperature climbs, like if you're giving it more throttle, this will open further as it needs more cooling.
Right.
It's being controlled by the temperature, and so this little valve is always kind of finding its home to keep the temperature where you want it to be.
It's always working somewhere.
What causes them to fail?
Well, like in this case, I'm guessing the shaft seized up because it's stuck halfway. The wax pellets can, if they get, if the seal goes bad in them, the pressure no longer will open the thermostat. They can fail one of two ways. They can either fail in the closed position, which is generally a big problem because then it overheats, or they fail in the open position, and that's when your engines never come up to temperature. And a lot of people will run them that way for years because it's very common for them to fail in the open position.
Yeah.
The other thing I've seen, not uncommon, is this little A-frame here will break. And so now what'll happen is even though the pellet's doing its thing and expanding, it's got nothing to push against, so the thermostat stays closed. I probably see that as the most common failure of the thermostat.
Seriously, a structural failure?
Yeah, they break here.
Jeez.
And what you were saying about, in the case of when it's closed, it diverts the water to the exhaust and then
Yeah,
out.
back out to the ocean.
That's unique to a boat,
Or-
right? Because in a car, it would just
Well,
stay closed.
In a
and there's
closed
no
cooling
bypass.
system, same thing, in a closed cooling system in a boat or in a
Yeah.
car, it would bypass the engine block and go directly back to the heat exchanger, or in a car to the radiator.
Oh, okay, okay.
I'm glad you brought that up, because I was talking about a raw water or open cooling system, it dumps back out
Yeah.
into the exhaust. In a closed system,
goes
it
back
just
to the heat
bypasses
exchanger.
the engine block and goes directly back to the heat exchanger.
Have thermostats gotten better over the years? It seems like you don't run into thermostats.
That's a matter of
like you used to.
opinion.
Yeah.
I think they've gotten worse because now, and I'm saying automotive in this case, thermostats are now controlled by the computer. They want to make the engines warm up quicker. So thermostats now have a wiring harness going to them with a little heater element in there. And this is very, and that's why you go with a modern car, a thermostat used to be, well, even at today's labor rates and
$10
stuff,
part.
a thermostat's $100 job, a traditional thermostat. Now, all of a sudden, a lot of these thermostats are $500 or $600 for the part,
Wow.
because it's controlled, it's an electronic part.
It's electronic, yeah.
And
It's electronic
the biggest
actuators.
failure I see with thermostats, you are partially right. I don't see thermostats failing, causing the overheating, that type of thing. Nowadays, the failure mode is the check engine light comes on. That's because the thermostat's not doing exactly what the computer wants it to do. And so $1,000 later, you get the little yellow light off, at least for a week until something else happens.
So what's the preventive maintenance or inspection you do on a thermostat periodically?
There's really not, other than if it's a closed system.
Yeah.
making sure the coolant's in good shape.
So you just have to wait
Some
for it to
people
fail?
will talk, some people will recommend changing it. That's another one of those, if you talk to 5 different mechanics, you're gonna get 5 different opinions. I'm of the belief that I check I will check the antifreeze. I have the test kit to check the pH level to see if it's if it's starting to get acidic or, if the pH is off. Obviously, physically, if it's clean, and I'll check the level of the protection, particularly in an automobile. Although even in a boat, you still want a 50-50 mix, because the proper amount of antifreeze, normally antifreeze is 50-50 mix with water. You still want the same mixture because it's also a better coolant when it's mixed properly.
That's the test
But
through
my
the
belief
squeeze
is
thing.
you either use the test strips, or I've got the one we add the drops of fluid to check the color to condition the antifreeze. And if the antifreeze is good, I'll just dump a bottle of additive, the water pump lubricant and anti-corrosion additive. You get a little bottle of it. I dump it in and keep running it. To me, antifreeze itself doesn't wear out. So if it's not contaminated, if it's not dirty, I don't see any reason to change it. And to me, again, this is my opinion here now, but I feel like that's a service that a lot of, over the years, particularly the automotive industry, even the manufacturers have come up with all these crazy services basically to make money. It's not that it needs to be done. When I used to work at the Ford dealership, we used to do an AC service, and this was back in like late 70s, early 80s, where we would literally pull the valves and dump the Freon out into the air, because this was before they decided it was before they realized how harmful that is. Freon doesn't go bad, but it was a $200 service that people would have it done. So we would just vent all the Freon, evacuate and recharge the system, and charge people a couple $100. And the dealers had it on their flyers. This is a recommended service. Looking back, I'm like, that was the stupidest thing in the world. There's absolutely no benefit to doing that. And again, with the antifreeze, you can check it. With coolant, you can test it.
Rusty, where can you get these coolant test kits?
Auto parts stores, generally.
Is that the tester with like the squeeze thing, and then it's
Well,
got
the one with the
it's got
squeeze thing,
the float?
yeah, that tests the protection level or the amount of ethylene glycol in it. What I'm talking about, that's one of the tests, and the other one is again, test the pH level, because that does happen. It is, as cooling systems degrade as they get older, then the coolant will become acidic. It'll be then you deal with corrosion issues.
Yeah.
So I'm not saying that you should leave your coolant in there for 10 years, but I am saying potentially you can if you test it periodically and it's in good shape.
Yeah. Well, funny you should say that, because mine's been in there for about 10 years. I don't have a lot of hours on the engine, if that makes a difference, but it's way past time to do something about it.
Yeah. I mean, at 10 years, I would recommend checking if it's clean. I mean, the first thing, obviously, take the cap off
Well, I mean,
of the reservoir.
small diesel. And
Yeah.
It's like if I get down to the boat before the end of the class, I'll take some pictures of my engine room.
Yeah.
I mean, fortunately, there's the coolant overflow is a translucent little tank that's kind of right here where I can actually see it.
Yeah.
And I can see what the color looks like.
Yeah. Now, is it still a nice green or
Yellow.
yellow?
Yeah. Look, it doesn't look,
You're not seeing you're not seeing rust color.
no, not at all. So,
Rusty, I have a question going backwards again, but talking about as water moves through, why do sailboats pump overboard and powerboats put the water out the exhaust? Is there a difference between how the engines work, or why one pumps versus one expels through?
Well, most of them go through the exhaust. Even the
Mine-
sailboats, as
mine-
far as
mine-
I'm
mine goes through the exhaust.
No, 'cause I'm used to this, like the sailboats, you always see the telltale of the water thing kind of pumping, it's I just figured it was,
The only real difference, oftentimes sailboats, because of the fact they heel over, they'll have the outlet higher, so a lot of times sailboats' exhaust is above the water line.
Yeah.
Other than that, there's no real difference. I mean, it's still pumping water and exhaust out,
right.
because they're relying on that cooling water to cool the exhaust system as well as the engine.
So water's going through both, but it's filling above the water line.
Pretty much it's the same idea, it's just in a sailboat, oftentimes the outlet is above the water line, so you see the water, whereas in a power boat, it's usually coming out through, if it's a stern drive, through the out drive, or the exhaust outlets tend to be below the, you know, unless it's one of those really loud, annoying go-fast boats, and then those actually dump the water out up high too.
Well, I know the sailors in the room, but I know I've had issues, well, I've been on a sailboat with friends who own them. But sometimes with sails up, they're under power, but they still wanna act like a sailboat.
Right.
And take right away, but it's one of those, when the engine's running, you can tell, but it's when you're a powerboat, stop taking. Cedar turn, you know what I mean?
Yeah, oh yeah.
But there's a lot, and that's why I'm just, so I just don't know if that was part of it, because it's to identify a sailboat to powerboat, or.
No, it's just a
that
design.
difference?
Yeah, it's just a design of the hull, the way they.
So my exhaust is above the water line, but it's like under the transom. So if I'm heeled over and I do have the engine running for whatever reason, that exhaust could be underwater.
Yeah.
Is there enough like pressure coming out of the exhaust manifold that that's not a problem, that it's still just pumping out?
Yeah, it'll generally, the exhaust will push the water out, which actually you're leading right into the next thing we're gonna talk about is the anti-siphon valves and water loops or water locks. Sailboats generally will have a loop of the exhaust that goes up high because of the fact sailboats heel over. You don't want a situation where the entire exhaust system is below the water line. On a power boat, that loop usually is up by the engine. As I said, the risers or exhaust elbows are up high. But on sailboats, the engines tend to be deeper below the water line. Hence, they will have a anti-siphon valve or a water lock or water loop. And basically, that's part of it is if you are in a situation where your exhaust outlet is below the water line, if you've been out, you're coming into the harbor, you've been under power, engine's hot, everything's up to temperature, you shut it down, now overnight everything drops, the temperature drops. What's going to happen to the pressure inside that exhaust system and engine? As everything cools off, you're going to end up, if the exhaust is underwater, you're now going to create a vacuum, because as everything cools down, it will create a suction, which potentially can pull water back into the engine. And that's the purpose of the anti-siphon valve. And again, on a sailboat, the engine is often below the water line, so that not only it may not just start sucking a little water in, you could end up literally starting a siphon into your boat.
I have a question. On an indirect cooling system, is the thermostat only on the closed system, or does the raw water system have any?
Yes, they have a thermostat as well.
Oh, they do?
Yep. It's basically it does the exact same function. Really to get back to, I said earlier, the indirect system and the direct system, as far as the engine part of it, are exactly the same. The only difference is the indirect system has added an intercooler for the water. Instead of taking cool water right from the lake, it's cooling off the water that's circulating through the engine.
Right, I get that, but
So literally,
does the raw water just go through the intercooler no matter what? Once you start the engine and it's pulling water through your through your.
Yes,
your
there's
sea
no,
strainer
I
and
see what
through
you're
your
saying,
impeller
yeah.
and your water pump, or.
Yeah, the raw water side of a closed system has no thermostat in
Okay,
it. The
that's my
thermostat's in
question.
the engine side.
Okay,
Okay.
so I don't need to warm my engine up to flush my raw water system.
No. The other thing I recommend is if your heat exchangers are reasonably accessible, with mine, every fall, I actually would take, usually there's one big, there's bolts that hold them together. I usually take the end caps off. And again, depending on where they're located, I would just take the hose and I'd blast the hose through them and put them back together, just to get them good and clean. And then I'm a believer in, once I did that, I would then fill the raw water side with non-toxic antifreeze.
Right, I
Just
ran Barnacle Buster through it, and then I ran fresh water, and then I filled
Yeah.
it with the antifreeze.
The other thing that they show on page 33, figure 33, page 33, a water lock is basically a one-way valve. And again, this is in sailboats, and that's basically to prevent, if you're in a following sea and you're taking waves astern, to basically, it's a one-way, it'll let the exhaust out, but it won't let the water back in.
Mm-hmm.
So that again, you can't, if you're, particularly if the engine's not running,
Mm-hmm.
that you're not taking water into the engine.
That can also happen in a power boat too, right? If you're humming along and you come off the throttle hard, the boat slows down and you've got,
Yeah, they're generally, the systems, that's part with the risers, and
yeah,
they're usually pretty well designed so that that's not likely to happen.
okay.
But technically, it is a potential, yeah.
Yeah, cause I always thought, like, except in an emergency situation, you shouldn't come down hard off the throttle because you can get that surge.
Basically, in answer to your question, I have never seen,
Okay.
in all the years that I've been working around marinas, I have not really seen that happen to cause an engine failure.
Okay.
I suppose, again, in theory, it probably can.
Yeah,
But
I mean, you might swamp the boat.
yeah, that I've seen.
Yeah. Well, thankfully, when you do that, the stern tends to come up, so you're not gonna get, but, yeah. It usually picks up the boat.
Alright.
So when people go overboard,
Keeps me entertained.
You go from this to this to this.
It took my wife a number of years to get used to all the intricacy, all the odd feelings of boating in general, because my wife had never been on a boat in her life before she met me. And I've been into boats since I was a little kid. And, of course, when I met her, I was in my early 20s, and, I took some pleasure in horrifying her from time to time. So.
And she married you anyway.
Yeah, so I guess she was desperate.
it took a long time to convince my wife that when we're sailing and the boat heels, that it's not gonna go all the way
Yeah.
over.
My wife does not like to sail. She can't deal with the heeling. We've gone out a few times, and of course, the guy we went with, well, Ed Gagnon, he was kind of like to this day, he's still a big kid, but, he knew she didn't like that, so he used to torture her. And she didn't like it. She'd be down in the cabin, and she'd look at the window and see water. She'd be. All right. All right. So I'm going to move on to lubrication. And as we mentioned in the homework, the 4 primary functions of engine lubricating oil are to lubricate, seal, cool, and clean. And oil actually is a sealant. You particularly things like piston rings to the cylinder walls. I talked a little bit about that last time. And I've seen this happen when the engine gets flooded with fuel, washes the oil off the cylinder walls, and then it won't start. There's not enough compression because the oil is what actually completes the seal of the piston ring. And you know, it's usually that happens on older engines that are tired. Any of the clearances are a little wide anyway. But I know in my years have been several times where we've had an engine that just spun over, it wouldn't start. Everything was there, but the compression was just too low to start.
So did
We
you
took
pull
the
out the
spark
spark plug
plugs
and you
out,
squirt oil in there?
Put a squirt of oil in each
Oh,
cylinder.
that's why you do that, okay.
Hit the key, and other than getting a whole bunch of smoke on startup.
I didn't know that either.
And as a matter of fact, the old Mazda RX-7s, the old rotary engines, were known for that. When they were fuel injected on a cold morning, they wouldn't start. They just immediately flood them with excess fuel. And the only way to get those cars started once you did that was first you had to get them in a shop where they were warm, pull the spark plugs out. I'd let them sit overnight. They were a real bear to get them running, and then squirt gear oil, 90-weight gear oil into they're not actually cylinders in a rotary, but you'd squirt gear oil in there, slowly turn it by hand, then put your plugs in and fire it up.
Jeez.
And then wait for the phone calls from the neighbors because they thought the shop was on fire. Boy, did they make smoke when you did that.
With gear oil?
That's heavy duty oil too.
Yeah, but that was the procedure, and that was right from Mazda. They said that's what you need to do when those get flooded. But my point being that oil is definitely a sealant as well. You don't really think of that. The third one that a lot of people don't think of, oil is also a coolant. And I haven't done this course in a couple of years because of COVID. I don't remember the percentages, but on a modern engine, you get, I want to say 20, I think the oil takes away 20% of the heat generated by the engine.
Jeez.
It actually is a considerable amount. The cooling system only takes like 70%.
Is that the reason on a diesel then, because it gets so hot, you need an oil cooler that cools
Yeah,
the oil?
actually a lot of modern engines use oil coolers.
They do,
not
even
just-
gas engines as
Even
well?
gas engines.
Okay.
And it's actually not a new idea. VW was putting oil coolers in their air-cooled engines since the 40s.
Long time. I know, I don't have an air-cooled engine in my teeny tiny diesel, but one of the boats I was shopping, was a much bigger boat, bigger engine, and that had an oil cooler.
Yeah.
It happened to have a high pressure leak, which is why I didn't buy that boat. But, yeah, it had an oil cooler.
Yeah. That's something, something to be aware of if you have, because oftentimes you may have an oil cooler that you don't even know you have.
Yeah.
It's not something they generally talk about. There's not really a lot of maintenance involved, other than if you have an oil cooler, making sure that you get all the water, all the fresh water out of it, or seawater, when you store it. I know I learned the hard way on a power steering cooler on one of my boats. Because I don't really trust these kits you buy to pump coolant, and I always actually drain the block. I usually flush it. I open the drains, flush it out, because the boat I have at the lake is raw water cooled.
Right.
I get all the sand and dirt, and I get everything out. I actually undo the plugs, hook the hose up, and run it for a few minutes with the drain plugs out of the block. So that the pump is actually forcing water, dirt. You'd be surprised at the debris that comes out. And then I let it drain, and then I refill it with antifreeze, and that way I know, okay, I put 3.5 gallons in. I know it's, everything is protected. Well, the first year I did it, I didn't even think about the power steering cooler is in line. That still had water in it, fresh water. And in the spring, I got it started, you know, I fired the boat up, started to go across the lake, all of a sudden there's this milky pink film going everywhere. It had ruptured internally, so it was pumping seawater into the power steering. You know, unfortunately, those are some of the nuances you gotta be careful of when you're, the first time you do it yourself.
But you said you
Don't
drain
panic.
the block because you don't like leaving the coolant antifreeze in?
Well, I'm talking about a raw water cool. So the block is full of seawater, or in my case, lake water. I like to flush it
Oh.
out.
So after you do that, just for storage, you're saying you.
When I'm
add it in.
storing it, yeah.
Gotcha, okay. I thought you were refilling the closed system.
Yeah,
No,
now
you're
the
not-
closed system, I was saying
Closed
earlier,
system.
I'll usually test it, and if it's good, it's
Gotcha.
good.
Okay.
Um,
So what you were saying is you flush it, but then you still fill it. You don't leave it empty, you're filling
Yeah,
it with
then I,
antifreeze.
basically, after I flushed it all out, then I'll put all the drains back in. And then literally, I'll take a hose off on top and pour, and I know my boat takes to do the block and both manifolds, I will use about 3.5 gallons of coolant. I use the RV antifreeze,
Okay.
non-toxic.
And that makes sure that there's no
And
water left in the
That
system.
way I know if I put 3.5 gallons in there, that I got all the water out.
You're
'Cause
using,
that's,
you're using the RV water line type.
yes,
For
yeah,
antifreeze,
the
not-
stuff that I can,
Yeah.
you know, that I can safely just pump back into the lake when I start it in the spring. Years ago, I used to use automotive antifreeze. The downside to that was I had to drain it into a container and, you know, flush it all out before I could put the boat in the water.
So I bought a bottle of the RV and I was reading the back. And it said not to use on diesel engines. And I'm thinking, do they mean don't use this as the antifreeze that you put in the closed system? Because clearly it's for the, you know.
Yeah,
the-
I haven't heard of that because,
I'll have to go check.
you definitely don't, it's not a coolant. You don't
Correct,
use
right,
it as
but
a
if
coolant.
you,
but
using
it's-
it for the raw water
Yeah.
heat exchanger part.
Yeah.
That's kind of close to the diesel, but it's not, so I just thought that
Yeah.
was weird wording.
Yeah, I
I think they were
don't
trying to
know
say,
what to
don't
tell you,
use this
'cause-
as the closed system coolant.
Yeah, you don't, because that has no, you know, that does not have the actual coolant has things that enhance the
Right.
transfer of heat.
Right, right. Yeah.
It's got multiple
Right.
additives
It's not
to prevent
antifreeze coolant.
corrosion, and whereas the pink stuff or the RV antifreeze, that does have additives also for corrosion, but it's not designed to transfer heat. Secondly, those additives are designed to last one season. They're not, that's not something that's designed to be heated and cooled.
Right.
And if you've ever done it, when you drain that stuff out in the spring, it usually comes out almost clear. I don't know what happens to it. It goes in pink, but in the spring, it's
goes
almost
somewhere.
clear. The color, it's, because I use it, I have a high pressure washer, you know, diesel fired high pressure washer. And my garage isn't heated, so in the fall, when I'm done using it, I use that, I fill all the coils. And in the spring, I just pump it into a bucket, and it always surprises me, because it comes out looking like water. It went in bright pink and came out clear.
How's it taste?
Hmm?
How's it taste?
Unfortunately, I can tell you how it tastes if ever viewed it. So fortunately, it's non-toxic. All right, and then the last thing is obviously oil is clean, as in, you know, most applications nowadays have oil filters, so it's taking contaminants, carbon, moisture, and basically conveying that contaminants to the filter.
In figure 37, does the lubrication oil get into the combustion chamber?
It's not supposed to.
Right, that's what the rings are.
You know, and I shouldn't say that, a minute amount does,
The
because
rings are keeping.
there's a film on the cylinder walls. And this is something I've told, but all internal combustion engines are generally going to consume some amount of oil. If the engine's in good shape, it's gonna be almost immeasurable. But, you know, I tell anybody, again, in automotive terms, you know, if you have to put a quart of oil in after 3,000 or 4,000 miles, that's really not a problem.
So when they say the car is burning oil, is that because oil's getting into the combustion
That
chamber?
usually means the piston rings are worn,
Okay.
the bearings are worn. And what happens when the bearings get worn, it throws so much oil on the cylinder walls that the rings can't handle it. In other words, there's supposed to be a 1.5 thousandths of an inch of clearance between the inside of between the crank journal and the bearings that rides on it. And that should have a high pressure oil film. When they get worn, all of a sudden now you've got 5 thousandths, a lot more oil is gonna bleed out of there. And it sprays up on the cylinder walls, which, again, if your piston rings are somewhat worn, they're not gonna be able to handle, so the oil's gonna end up getting past the rings. And that's usually, you know, again, a worn out, unless something unusual's happened, a worn out engine is usually everything is worn. The other thing is they show, even you can see in that picture, the valves, which are coming down from up above. The valves ride, they call valve guides, which is like a tube that valve rides in. That should be a fairly tight fit. Again, 1/1000th of an inch. When they get worn, now all of a sudden oil runs down those valve guides
Into the cylinder.
and gets into the cylinder. And so that's why when you get as engines get older and tired, they start using oil. However, you know, just because an engine's starting to use some oil doesn't necessarily mean it's at the end of its life. It means you got to keep an eye on the oil. You know, I've got an old Ford Ranchero that when I bought it, it was using a quart of oil every 600-700 miles. You know, it's a fair amount of oil consumption. Not really blowing any visible smoke, but it was burning oil. I've put 35,000 miles on that car, and it still uses a quart of oil every 600 or 700 miles. You know, I know the car it's a 1978 car with 150,000 miles, and the engine's never been apart. And engines didn't, nowadays 150,000 isn't a big deal, but in 1978, that, for an engine to go that far without ever being taken apart is pretty unusual.
That was a lot.
You know, and also it's a toy for me. I don't drive it every day, so I really don't care. You know, it's a quart of oil every 600 or 700 miles is maybe 2 quarts a year for me. You know?
How many vehicles do you own?
I always get that question.
Yeah.
I'm embarrassed to say I honestly don't know. I have to count. And you
Approximately.
also have
Not
to
enough, right?
you also have to ask, when you say vehicles, do you mean
Partially.
registered and drivable, or do you mean everything that's half apart and may or may not ever see the road again?
I withdraw the question.
And you count boats as a vehicle too.
No, that's a good question too.
Yeah, well, we're not even gonna go there. If we count boats, backhoes, tractors,
Oh,
there's a reason why I bought 3 acres of land out in the country and then built a barn bigger than our house.
I think we should have the last class in your
I
barn.
think so too.
I actually used to do that.
Did you? I bet it's cool.
I'd love to see it.
But, and again, we might, you know, if there's interest, I might do a last,
Field trip.
yeah, literally, because what I've done in the past is I'll bring a boat down there and just kind of go through a quick winterizing procedure.
Cool. I'm in.
To show us how to rebuild a, Chevy 350.
In 2 hours.
Alright, and alright, now we're gonna get ignition system. Alright, I'm gonna start by covering a distributor type ignition system, which again is unfortunately rapidly going the way of the dinosaur, because everything's becoming distributorless ignition. Except for the exam, so we're gonna cover the distribution. And as far as I'm concerned, you can have this distributorless electronic stuff. It's very expensive and I find troublesome. I find with a little maintenance, the old ignition systems rarely gave you, especially when we get into the electronic ignition systems in the distributor. Every 20 years or so, you put a set of spark plug wires in it. Every few years you throw a set of spark plugs in it, and they generally just keep going. But the ignition coil is, basically it's a transformer. Its purpose, 12 volts. Well, again, to step back a little, I'm briefly just going to cover the whole voltage, voltage versus amperage, and the way I kind of the easier to put it is if you think of a water pipe, and the electricity being water, the current flow. I put it as the voltage is the amount of pressure pushing the current flow. The amperage would be, again, this is a vague thing, but more equivalent to the diameter of the pipe. Is, in other words, how much comes through. And then wattage would be the combination of the two, how much pressure and amperage flow would give you, so what your end result is, or gallons per minute in water. And I just, as a quick, very crude and basic explanation, but I just mentioned that because we're going to talk about voltage and amperage with the coil. So the ignition coil basically works by it's basically a magnetic induction. You have the primary side of the coil, or your 12 volt side of the coil, and the windings, the windings within the coil is a fairly heavy gauge wire that might have, I'm thinking in terms of just a traditional coil, maybe 100 turns of wire on that coil. Now, right next to it, you will have the secondary side, which is your high voltage side, and you will have a much finer wire, but there may be 5,000 turns of coils of wire. And now, if you think back to high school, what happens when you put electricity through a coil of wire?
You suck the nail right up into it.
Yeah, you get magnetism. Or correct, magnetic lines of flux is a more technical term. And so whenever you expand or collapse, basically you turn that power on or off. When a magnetic field collapses, it induces a voltage into the other wires next to it. So if you have a small amount of voltage that you're inducing from, say, the 100 turns of wire, now you're getting a very small, but a given amount of voltage from each coil of wire on the secondary side, so that what started out as 12 volts on the primary side is multiplied times the thousands of turns of wire in there. So now all of a sudden, instead of being 12 volts, when you collapse that magnetic field, you're inducing 5,000 volts or 10,000 volts. It's all determined by the number of turns, the amount of wire in there.
And that's the kind of voltage that's delivered to
And
the spark
the
plug?
spark plugs need 5, and again, don't quote me on these numbers, I'm just throwing, but they need 10,000 volts because again, the voltage is the pressure that's pushing the electron flow
Across
over the gap.
Across the air gap.
12 volts isn't enough
Isn't
pressure
enough,
to
right.
jump that gap. Now, the downside, it's not really a downside, but the other side of the coin is because we're getting so much more voltage, it's still the same amount of power to begin with. So the wattage hasn't really changed. So the primary side, you'll have 12 volts at, let's say, 5 amps. On the secondary side or the spark plug side, you may have 10,000 volts, but you've got, fractions of a percentage of amperage. In other words, the amperage is very, very low. And hence, it's the reason that the secondary side, unless you have a pacemaker or something like that, even though it's 10,000 volts, the amperage is so low, even if you hang on to that wire, it'll get your attention, but it's probably not going to kill you.
Imagine get your attention from a really big.
So you would need voltage and amperage in order to kill you.
Yeah, if you wanted to fry somebody, you need voltage and amperage.
And
But,
it depends on exactly where it's applied too.
Right.
but again, and don't go grabbing the plug wires just to test my theory because state of health can vary. So.
Fortunately,
I'm
my
on
boat-
camera here. I have to throw that disclaimer in.
Fortunately, my boat
Test
doesn't
it
have
with your
spark
tongue,
plugs,
right?
so it's okay. I say,
Yeah.
fortunately, my boat does not have spark plugs,
Yeah.
so I'm safe.
Yeah.
Don't put your tongue on the coil.
Yeah, don't put
Yeah.
your tongue in the coil. Yeah.
Yeah. Well, diesels have their own set of hazards
It's-
too.
oh, yeah, for
You've
sure,
got
but-
high pressure
Hmm.
liquid, which can be as deadly.
Yeah.
So anyway, in a real quick explanation, that's basically the coil is a transformer. Now, as I was talking about, in order for this induction of voltage to take place, you can't just turn power on. The power has to pulsate. In other words, you have to shut that magnetic field down to induce that power. And that's where traditionally the breaker points have come in, which is basically just a switch. That as each cylinder fires, the points will open up to collapse that magnetic field. Nowadays, it's done with electronics. There's a sensor in the distributor and an electronic module that switches the power. But it's still the same. And
So timing must be critical to all this.
yes, the timing is very critical. So then at that point, we've got the high voltage spark. Now we need to distribute it at the appropriate time to the cylinders,
To the right side.
To the right.
to the proper. I
So
will pass
is the
down-
ignition coil delivering a constant voltage to the distributor?
Well, it's a pulsating volt. It's it's basically a pulsating voltage.
Okay.
Because it's not really alternating current, because technically alternating current is reversing current flow all the time. Whereas this is not really alternating. It's a
Jim, think of a series of pulses like this.
Right.
where each of those is where the breaker is telling the coil to do its thing. So, and they're all the same width.
But yeah, it's basically just a pulsating.
So each of these is one of those pulses that, fires the spark plug.
Yeah, I'll tell you what, start an engine and grab a spark plug wire and you'll feel exactly what the pulsating feels like.
They're really short.
Use your tongue.
I'm gonna pass this around as a distributor, and you can actually, you can look in here and see as you turn this, you can watch these breaker points open and close. And that's basically the switch in the 12-volt side of the system. And those opening and closing are what create that pulsate, the pulsing 12 volts, which makes the transformer work. Now you have the high tension or high voltage spark coming out of the ignition coil. Now the way we get it to the spark plugs, the appropriate plugs, is through hence the name distributor. When this is on here, I'm going to pass this around with it. The high tension wire from the coil is going to go into this middle point, which on the inside is against that little tab. As this rotates, it literally lines up, and again, you'll see the contacts in here, and this almost touches so that the spark can easily pass. And again, this all has to be timed so that the spark is at the right time. This has to be lined up with the appropriate tower to carry the spark to the spark plugs.
Where is that wire going?
And this wire here, this, like I said, these points are a switch.
Yeah.
The points are grounded. All right, when they're closed. So this switch basically takes this wire and switches it to ground, turns it on and off from ground. So this would go to the ignition, the negative side of the ignition coil. And they show it here. The positive side of the ignition coil would be getting 12 volts from your key.
Yeah.
So what's happening now is as these points are opening and closing, it's completing this circuit. And again, they show the breaker points in the diagram, figure 40. But as those close, when those close, they complete the circuit.
Mm-hmm.
When they open, they break the circuit, which collapses the field, induces the spark.
Wow.
And
All in a split second.
yeah, a lot more than a split second.
Mm.
And it has to be timed, so that's why.
And yeah, this
goes
is
through the
timed.
block and
It's
rides on the
timed so
camshaft.
that when we talked about how the pistons are top dead center, you get your spark. It's all, and this has to be timed so that the proper pull on this cap is getting the spark to go to that particular cylinder. And I actually put together a live ignition system that actually works. So you're probably gonna wanna come over to see that.
Is it in your box?
Huh?
Is it in your box?
Yep. Well, it's not in the box, but I brought it with me.
There's a cap that goes over that with the wires going to the spark plug.
Yeah, that's the cap, I didn't bring the
Yeah.
wires,
Yeah.
but you'll see it here.
What's that on the side? Is that vacuum?
Yeah, that actually is, because that's out of an automobile, it has a vacuum advance. Marine engines generally don't use that,
Okay.
so that's why I didn't really even mention it.
Okay.
But after you start the car using the battery, all this has to keep going.
Yeah.
So why does this drawing only show the power source being the battery?
Well, the ignition system, this is battery ignition. It continues to require voltage to run.
Yeah.
And hence the purpose of the alternator as we were talking about earlier, to continually supply
So it's
that.
always gonna go to the battery,
So, yeah, battery ignition is always gonna,
have to pass to the battery.
and again, I'll put this up there so you guys can play with it. I actually have a battery strapped to the back.
Unless there's a certain order you have to put those caps on, right?
The wires.
The
The
wires.
wires, yes,
Yes.
and that's, I can't tell you how many mechanics I've had working for me that have crossed wires. They do a tune-up and then the car won't run.
I did that once, the engine came out.
So on this, basically this toggle switch is your ignition switch. And actually, you can actually see if you turn the distributor,
Yep. I love this.
it fires all the spark plugs. Each time the points close, and it's basically doing the same thing as that distributor. Oh, yeah, like I said, we can come around and,
That's fascinating.
That is a great show and tell.
Yeah, it is.
Awesome.
Where's the battery?
the battery's in the
It's on
back.
the back.
That's a little,
Guy hat.
How many volts are you feeding through that?
12 volts.
Okay.
But again, this
What's the
ignition
motor?
coil is converting that to probably, this is an old points type, this is probably around, I don't know, 9,000 volts. I mean, if you wanna come over here and grab one of these, you can tell me.
Yeah.
Oh,
Get it on
He keeps
camera.
on, he keeps on inviting me to do that.
Put it under your tongue.
Yeah. Put my finger. Put
Your
my
hair will
fingers in.
stand up. And then at the emergency room, they can understand what happened.
That's right.
But yeah, before you take off, anyone wants to look at this and we can,
Impressive.
and that's why I brought that, so you can see what's going on inside there.
I think for next week, you should bring in a fully functional engine that we
Well, you laugh, we're not that far front, cause this, as we get further on, this,
Except
in the box.
except from 10 different vehicles.
well, there's a 4-horse Johnson that basically before we're done,
Yeah.
we're gonna put it together.
Oh,
The pieces are all in there.
all right.
It's hard to put it together.
Yeah. And bring in
And I'm actually working, I'm hoping to have it for this group. I actually scrounged up an old outboard, and I'm gonna try to do a cutaway of the lower unit, so when we get into that section,
Oh, that'd be
you can
great.
see how the gears all work. Cause that's another one of those kind of a mysterious, and I don't know if I can make, the problem is trying to make them still work, cut away enough to see without
Right.
making it non-functional.
So the housing is functional, you're saying?
Alright, so now we're getting further behind.
But we're having such a good time and learning a lot.
We have toys to play with.
You gotta have toys.
Show and tell.
Yeah, it's interesting, just, I know we're getting late on time, but, and again, as we point out in the homework, the alternator has pretty much become the norm for recharging batteries. I don't even think they meant, in this, for the purposes of this course, I don't even think they mention generators anymore. The biggest problem with generators is, one, at low RPM, generators don't put out much current. In fact, oftentimes, anybody that had cars in the quote old days, and I'm going back to like 60s, you came to a stoplight, it wasn't uncommon for the generator light to kind of blink at you because
I remember that.
it wasn't putting enough, the generator wasn't putting out enough, you were drawing more power off the battery than the generator was putting
Yeah.
back.
I remember that happening.
So did you say that the generator on a boat is really an alternator, not a
Yeah,
generator?
it's not a generator, it's an alternator.
Okay.
Now, that's one of those things, the term generator has kind of stuck, because I noticed to this day, I still see dashboards labeled generator, even though there hasn't been a generator in a production vehicle for 25 years.
So the generator, separate generator on a boat just is an engine that turns an alternator?
Yes, you're talking about a,
Like
yeah,
a 6
gen set.
kilowatt
Yeah.
or a 12 kilowatt
yeah,
generator?
yeah, those are generally alternators.
Cause they're more efficient than generators.
Well, they're
Yeah.
also, they're not rectified, so they're
Um,
generating AC current.
And again, I should qualify, there are probably still generators out there that have that work with an inverter to give you the alternating current. I'm not that up to date on that stuff, so. It just seemed, but unless you had a need for something other than just plain old 110 volt or 220 AC, it seems it would be kind of cumbersome to generate DC voltage less efficiently and then convert it to AC
yeah.
versus just generating AC to begin with. And
So then, yeah, I'll just wonder, so they must be, for the generator to recharge the batteries, there's gotta be some sort of device to step it back to the proper.
yeah,
the
either a
DC
generator
engine.
or an alternator will have a voltage regulator,
Well,
which is basically it's like a thermostat in your house. It controls, because an alternator works, again, actually on the same principle, we were talking the ignition coil. It's magnetic, it's induction is how an alternator works. You're spinning a magnetic field, and the field windings are producing the electricity. Now, the way they control the output of an alternator is by controlling how much voltage is allowed to go into that field, that magnetic field. So if you put a quarter of an amp in, and given that the alternator is spinning at, I'm just gonna pick a number, 2000 RPM. If the RPM stays the same, if you give the field a quarter of an amp, let's say you get 20 amps out of the output of the alternator. If you increase that to a half an amp, now you're going to get 40 amps out of the alternator. Or if you decrease it, you'll get less. Literally to the point where a voltage regulator at some points will stop it altogether so that the generator is just freewheeling. It's not producing or alternator isn't producing anything
Right, cause there's no load.
because it's not needed.
What's the difference then between a generator, or the alternator and a generator charging your house batteries and your main engine, alternator charging your house batteries? Is it the exact same thing? Or is the generator more efficient at it than the?
That would depend on what you've got, how your boat's set up.
Yeah.
Like I know in my case, I have mine has an onboard dual bank battery charger,
Right,
which powers off of shore power.
right,
Now, a lot of boats, your generator basically supplies the 110 volt AC to the battery
charger.
Yeah.
But if your engine is running.
If your engine is running, now you're charging the alternator on the engine is now charging the batteries directly, because the alternator is putting out 12 volts, not 110.
Okay, so if you've got a generator and you're charging batteries from your generator, the generator is not charging the batteries, the battery charger is charging the batteries?
Yeah, it's just
That
like
would-
you're plugged into the
Yeah,
dock
basically a
and-
generator is supplying your main bus panel, just like you were plugged into shore power.
Okay.
Yeah.
And again, I'm saying this generally, I'm sure there are exceptions, but as a general rule, that's my understanding.
Well, there are
And
charger
charging
inverters
units.
that are combination units, but in most cases, just like
Yeah.
when you run your generator, you're producing 110 volts, and
Right.
110 volts is powering the charger, which is charging your battery.
Right.
So it's kind of it all goes together.
But your house batteries, not your starting batteries.
Right.
It can charge both, any
Yeah.
battery that's connected to it.
Right, right.
Hopefully
It
your
is.
charger, your dual bank charger, one bank is going to your starting battery and the other bank is going to your house.
But the alternator on your engine then is not performing the same function.
No, the alternator in the engine is basically, its primary function is to recharge the
Is to
battery.
recharge the battery, whereas the generator is really providing 110 AC
The-
to your whole electrical system.
Generally, the generator, assuming you're talking about a standalone generator, is supplying the amenities. That's giving you your hot water heater, it's giving you a refrigerator, it's giving
Microwave.
you microwave, all that type of stuff.
Air
Your
conditioning.
generator generally has no connection with the engine running.
Right.
But also, as I pointed out at the beginning of this, remember, I am not a qualified marine mechanic. I'm a guy who screwed around with this stuff enough to know a little bit about it. So take everything I say with a grain of salt. I'm sure there's exceptions to just about everything I say.
Do you charge your batteries faster by having the generator and the engine running at the same time?
Again, now this is an opinion,
Yeah, that's
but
fine. And
generally I'd say no, because your alternator is basically, if you run your battery charger, then the voltage regulator is gonna say, oh, we're already seeing 14 volts, so
Oh.
it's basically gonna stop.
I see. Okay.
In fact, I know in an automobile, if you put a battery charger, like
Yes.
a roll around charger,
Mhm.
if you put that on when the car is running, oftentimes the alternator light will come on because the system will say, oh, the alternator's not working now, because the regulator will stop. It's
see.
already above the threshold that it's, because the way the voltage regulators work, they base on voltage. In a 12-volt system, when the alternator is running, that voltage regulator wants to see 13.5, 14 volts, somewhere in there. If the voltage starts to go over 14, that's when the regulator will cut back the amount of power it's giving the alternator to charge. So if you use your battery charger and all of a sudden it's already seeing 14 volts, the voltage regulator will say, oh, this battery's already overcharged, so we're not gonna allow the alternator to do anything.
How long does it take to roughly charge a battery? Because new boats have, I guess, the gel batteries, so they're taking generators out of boats with, we were looking at a Cutwater, and they've got gel, the 4 battery bank, but they've taken the generators out. It'll run the AC, it'll run all of the other stuff, but I'm assuming not for as long. But how long does it take to recharge that?
Yeah.
It depends on your
You mean
batteries,
a
it depends.
standalone genset or something coming?
No, they
up?
pulled the genset out of it,
Okay.
and now they're running it with gel type batteries.
Yeah, they're just
And the boat
pulling the
can,
power out
so
of
basically it
batteries.
can sustain itself for 4 or 5 days,
But straight
straight off the battery.
It uses the inverter to create the 110 volts? to
Yeah.
run
Yeah.
the boat?
Yeah,
Yeah.
probably as an
Yeah.
inverter. The problem
Yeah.
is inverters
Yeah.
are
Yeah, but inverters
really
just
tough
drain
on
your
battery life.
So you gotta be able to replenish your battery.
So that's what I'm saying, but I'm assuming you have to start the engine up to put power back in, but how long does that take? But they said you can.
I take it you don't have air conditioning then on
That-
on
that
that boat,
would-
right?
that
It does
depends.
basically.
It does?
As long as AC will run off the battery bank with
Yeah.
the new Cutwaters.
In answer to your question,
Yeah.
how long it would take to charge the batteries would largely depend on the capacity of your batteries, and it would also depend on the charging system. Do you have a 100 amp alternator, a 200 amp alternator?
And how far-
And also,
And-
I mean,
And depending on how far it's down,
The state of charge
Yeah.
as well,
Right.
whether it's, day 5 or day 1.
That's,
Right, well, that's what I was wondering.
You know,
Like, if
there-
you go
there's so
somewhere
many
for travel,
variables,
At
that's-
some point, you're not moving, so it's
Don't-
2 day
don't
overnight.
go too far.
Yeah.
But make sure your engine starting battery is on a separate circuit.
Yeah. That's the most important thing, is get your engine started.
Right.
Gotta protect that battery.
Which, I mean, we have that now, we have dual switches, so.
what I have always done, because like in my case, I did not have a dedicated starting battery. I had 2 batteries in my boat. And I used to actually alternate depending on the day of the week. If it was an even day, I'd run, when we'd like go out in the morning, I'd just run battery 2. If it was an odd number day, the 3rd or the 5th, I'd run battery 1. And that way the other battery would always be charged if I had a problem. I would just run 1 battery at a time. And that way we'd sit out at the sand spit with the kids, and you know, we'd use the batteries, and I really never had an issue, because I also was big on, I would replace my batteries like every 2 years. But what I do is sell the old ones, because they were perfectly fine. So before they died, I'd sell them to somebody who was cheap that didn't want to buy new and pay for half of my new ones. So, you know, every 2 years I just put new batteries in. But that, I found doing that even odd thing, I just, whatever the day it was, that way both batteries got equal use. And I was only running on one battery, so that if something got left on, or you know, when I killed a battery over the course of a day, because like we had a refrigerator and all that, and the refrigerator sucks down a lot of battery, especially when you got 3 kids and they're in it more than they're out.
So my boat has a starting battery and 2 house batteries.
Yeah.
But when I go out to start it, I always put the batteries to all. I start the engine, I leave the mooring, I motor out of the harbor on all. It's a sailboat, and when I get the sails up, I shut the motor off and I put the batteries to the 2 house
To the house
batteries.
batteries, yeah. Yeah, you'd also have to look and see what type of isolator you've got. Like on my boat, I put an isolator in mine so that it would charge, no matter where the switch was, the alternator would charge both batteries,
Right.
regardless of where the. Now that's a more expensive battery switch than just a basic one, but that way I never really had to worry about. They were always both batteries were being charged all the time.
How many batteries in your boat, Jim?
Me?
Yeah.
6.
That's 7, yeah.
6 volts or 12 volts?
I've got 4 6 volts for the house. I've got a starter battery for the engine, starter battery for the generator. I've got one for the windlass and one for the bow thruster.
Holy cow.
Yeah. So that's 1, 2, 3,
Alright,
4,
so for
5, 6,
next
8,
week,
excuse
we're
me,
gonna,
8. Yeah.
I don't have a separate one for my rental.
We'll get
so I don't
chapter
get
2.
Pardon?
For next week, we're gonna do chapter 2.
3 or 2?
I mean, sorry, 3.
Oh, that's not that long.
No, it's fairly short.